So this is me going over question 5, unit test 8, which was chapter 10. So this was the question that quite. So for part A, we've got to work out the acceleration A, acceleration B rather. So we've got B descending down from the edge of the table. Initial speed is 0. It's told that it's got a distance of 0 travel and it takes 0 seconds. So using S equals ut plus half at squared, we can see that its acceleration 2.25. Now for part B, we're being asked to work out the tension in the string. So again, just be very clear on your diagram. We've got two tensions which are equal and opposites both sides of the So make sure your arrows are pointing towards the pulley, two equal tensions here. So when we're looking at it from the point of view of B, the direction of movement is downwards, so we're going to resolve downwards. Using F equals ma, the weight of B, the 1.9 g, is greater than the tension. So as net force is 1.2 g minus the tension. F equals ma, its mass is 1.2. We've just worked out in part A that the acceleration was 2.8125. That allows us to work out that the tension is 8.85. Now for part C, we're being asked to work out the value of F. Now if we look at it from the point of view of A, we resolve in the direction of movement, which is to the right. Again, using F equals ma. Now with the net force for A, the tension's got to outweigh the force because we're going left to right, so the tension must be bigger. So our net force is going to be T minus F, equaling mass times acceleration. Well, the mass of A is 0.8, and obviously its acceleration is the same. It's a 2.8125. That allows us to work out that the force is 6.135. Now, for part D, we've got to work out the total distance travelled by A. Now, the first thing to take on board is this comprises two distances. It's first of all going to be the distance it travels while it's being pulled along by B. Well, B travels 0.9 meters before it hits the ground. So our final answer, we've got to remember to add on 0.9 meters. So the second distance we've got to work out is the distance that A travels once B hits the ground. And we lose the tension and it just carries on slowing down until the friction is such that it just stops. Okay, so you've just got to picture the journey of A. It starts off being pulled along quite merrily by B until it hits and B hits the ground, and then A will carry on its own, slowing down with the string being no longer being taut until it just comes to a rest before the pulley. Now, when we what we're going to need to know, one element we're going to know for A is going to be its initial speed as it starts its independent journey once B has hit the floor. So what is its initial speed as it starts its independent journey? That's going to be the final speed of B before B hits the ground. So looking at it from the point of view of B, the final velocity of B, which will be the initial velocity of A, is going to be, using V equals U plus AT. Well, the initial speed of B was 0 to start with. It accelerated at 2.8125 from part A, and it took a time of 0.8 seconds to hit the ground. So the final speed of B is 2.25 meters. And you'll see further down here that when we start looking at it from the point of view of A, that's therefore the initial speed of A as it starts its independent journey. Now, we really need to get to grips with what's going on with A once B's hit the ground. So I've done another diagram of the forces here. Now the tension is gone. The tension is no longer there. So we're not being pulled along. We're told that the frictional force remains constant throughout. So we've still got the friction of 6.135 going in the left-hand direction. So resolving to the right and using F equals ma, we're saying the force is minus 6.135, equaling the mass times the acceleration. So we can work out the acceleration is minus 7.66875, which is what we'd expect. We'd expect A to be decelerating as it just comes to a rest. So what do we know? So we know its initial speed is 2.25. We know its deceleration is minus 7.66875. We want to work out the distance it travels, and we know it comes to rest, so that we know its final speed is 0. So using v squared equals u squared plus 2as, we can now work out that this extra bit of distance that it travels once v's hit the ground is 0.33007 meters. So adding that on to the 0.9 meters, we get 1.23 rounded as our final answer.